and then we're going to go over it together. Coordinates. You can all do. You're answering that question right after. Let's take another minute or two.
How are you doing today, Miss?
I'm good. I'm cold.
How you cold? And you got jacket on.
Clearly, it's not a big enough jacket. It's freezing right now. Okay,
I say yes.
let's take a look. You've got 3 different points that are given there. And then if the question asks you to write the coordinates of the points, and then it asks you a question about reflection. So when you write the coordinates, which one comes first? X comes first, okay. So for point A, who can give me the coordinates of point A? What do you think? Negative what? Okay, which one comes first, Lorenzo? You just told me the X comes first. 4, okay. So this one's gonna be 4, comma, -1. Good. Who can give me the coordinates of point B? 5, 6. Good. And last, who can give me the coordinates of point C? Judge? 1, 3. Good. Okay. So you gotta at least be able to figure out how to graph points, right? Because we're gonna need that thing. So you've got your coordinates, and then the question says, if you were to reflect the triangle horizontally, would the reflection be the same size and shape? Why or why not, and how do you know? First of all, what does it mean to reflect something, Bobo? Put it on the other side, what do you mean? Whatever the line is, okay, put it on the other side. Reflection, think about like a mirror, right? Why would it be the same size and shape though, Bobo? Yeah, you're just looking in a mirror. Nothing's going to change about yourself like looking in a mirror. What does change though? The size or shape doesn't change, but what does change?
Coordinates.
The coordinates are going to change, right? If you look in a mirror, right, and you like raise your right hand, what does it look like you're raising in the mirror? Your left hand, right? So it's flipped essentially. Good. right, so today we're going to start talking about different types of geometric transformations. And the first one we're going to start with today, as I'm sure you can guess, are reflections. So we're going to be talking about some reflections today. We're going to watch ourselves a quick little video, and then we're going to do some notes today. So, your favorite, I know. I know you guys love doing notes. That's what we're all here for. We're here to learn, man. All right. Sorry. Probably defreeze. Okay, we're going to watch a quick video and then we're going to talk about it once the video is done. Except now it's just actually frozen. Oh, come on. Here we go. No. It's a video I found. Okay, this is terrible. Might have to keep it small. Maybe the only way that it's going to play. Come on, technology, you're killing me.
Reflection is a type of movement or change in a geometric shape. Think about when you look in a mirror. You see a...
Stop. There we go. Okay.
Reflection is a type of movement or change in a geometric shape. Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the left and right sides are reversed. The same is true with geometric shapes. When we reflect this triangle like this, the x-axis acts like a mirror. You can reflect all kinds of shapes, as long as you determine the line that you want to reflect on, just like a mirror. For example, you can use any line along the x-axis or the y-axis. You can even reflect a shape through a line using an expression such as x equals 1. In this example, the line x equals 1 is the line of reflection for the two triangles. You can use any expression to create a line of reflection anywhere. The way to make sure a shape is correctly reflected is to check that each point of one shape is the same distance from the line of reflection as the corresponding point in the other shape, and that it has corresponding sides and corresponding angles. Just like other transformations, you can record the coordinates of the shape and its image to demonstrate the reflection too. Reflection makes a mirror image. It's one type of movement for geometric shapes.
Okay. So part of that I want to just touch on briefly is okay. When we do reflections, right, when it comes to doing a geometric shape that's reflected across something, what you're going to have is you're going to have the coordinates of your original point, and that's called your pre-image. And then you're going to have coordinates of your new points. These are called the images. And what I want you to notice is that, bless you, as you go from the original one to the new ones, to show that it's a transformation, we put a little tick mark next to it. Right, so my original one has no tick marks. My A, B, and C in the new one has a little apostrophe. We call it a tick mark in math. Okay, so we're gonna get ourselves started here on some notes on reflection. So if you didn't grab that from the back, you can go grab it now. Go ahead and put your name on it and today's date. And you might want like a highlighter or something of that sort for today. If you have one, that would be grand. Okay, first one, a transformation is a function that maps a given figure called the pre-image onto a resulting figure called the image. So you start with your pre-image and you end at your image. So you got a starting point and an ending point. A rigid motion is a transformation that preserves the size and the shape. So as we do reflections, your size and shape of your picture should stay the same. If your picture doesn't look the same, then you're doing something wrong. Everything should stay the same. So a reflection is a rigid motion in which the figure and its image have opposite orientations. So in other words, it looks like it's backwards, right? When you look into a mirror, it looks like it's flipped. So we're going to start by reflecting some points across a line, and the line is essentially kind of acts like your mirror. So that'll tell you where to flip your picture based on wherever that line is. So the first thing I'm going to have you guys do is on this very first one here, I'm going to have you label this point A, B, and C. And I want you to take a second and just plot those points on that graph and label them, okay? So take a second. We're going to plot these points on the graph and label them. You should get a triangle. So take a sec, give it a try. Right, so your X is first, your X is the horizontal line, your Y is your up and down, and then I'm going to label this as my, this right here is called my pre-image. It's where I start. My pre-image. It's my beginning picture, right? Pre means before, so that's where I start. Okay, now I'm going to reflect the points across the X-axis. Okay. Which one is the X-axis? Show me with your hands. Is it this way or is it this way? Which one's X? Yeah, good. Okay, so I'm going to take this picture and I'm going to flip it across the X-axis. And when I flip it, it should be the same distance away on both sides. Okay, so I'm going to take this and I'm going to flip it below. So you have to think about if it's pointing kind of like upwards to the left, when I flip it, it's going to be pointing downwards, right? So I'm flipping it straight across. And all we're going to do is we're going to count how far away each point is from that yellow line. So if I start with point A, right? If you count point A to the yellow line, how many spaces away is it? 2. So it was 2 above the line. To flip it, I'm going to go 2 below the line. 1, 2. That's going to be my new point A. And when I write it, I'm going to put an A, again, with a little tick mark next to it, because that shows it's being transformed. What are the coordinates of this point A right here? What, comma, what?
3, 2.
3, -2. Good. So I'm going to put 3, -2. Let's do the same for B. How many spaces away is point B from the yellow line? 3. So it was 3 above, so I'm going to below. 1, 2, 3. I'm going to label it again as B with a little tick mark. We call it B prime. What are the coordinates of point B? What, comma, what? -1, -3. Good. Which this was my A prime and my B prime. And now last one, C prime. How far away is point C from the yellow line? 0. So if I don't go up or down, do I go up or down for the second one? No, so it stays in the same place. It's right on top of that same one. That's not only C, it's also C prime. And now I have a picture of a triangle that has been reflected, or a triangle that has been flipped. And I look at it and they look like they're the exact same size and shape, so I look good. What's the coordinates of that point C prime? 1, 0. That didn't change. Good. So this part in blue, my first one is called the pre-image. That's where I started. My ending one is called the image. So I start at the pre-image and I end at the image. Okay, now we're going to take a look at the rule or a pattern that we see. So as you're going from the pre-image to the image, what are you noticing is happening? How do the y's change? Oh, so they go from a positive to a negative. The numbers stay the same, except it goes from positive 2 to negative 2, positive 3 to negative 3. What about the x's? X's stay the same. Very good. That's my rule right there. My x's stay the same, and my y's change signs. Right? Because if I would have started down below and flipped it up above, it would have gone from negative to positive. So they're just changing signs. Well, how come the 0 didn't change signs? Because 0 is not positive or negative, so it just stays the same. Okay, so to write it as a rule, I say xy becomes x, comma, negative y. That says my x's stay the same, my y's change sign. Okay, there's your first reflection. How do you feel? Good. Do we have any questions? No. Okay, not too hard, right? So it should look the same when you reflect. It should be pretty easy just to look at the picture and figure out if it's a reflection or not. Okay, number 2, we're going to now reflect the points across the y-axis. So the first thing you're going to do is you're going to label your points A, B, and C. You're going to plot them on your graph, just like we did in the last one. In fact, I think they're the exact same points. So take a second and graph it. Oops, let me do this every time. It should be the exact same picture. Right, it's actually what you started with. And you should label all your points with A, B, and C. All right, this time it says, I want to reflect the points across the y-axis. Where is the y-axis located? Which one's the y-axis? Show me with your hands. Where is it? It's the straight line that's up and down, right? Okay, so I'm going to highlight it because that's how I'm going to know where I can reflect. So my y-axis, we're doing the same thing, except this time, instead of flipping my picture up and down, now I'm going to flip it left and right. Okay, so it's the same thing, except I'm just going to flip it a different way now. So let's start with our point A. If I'm going to flip it from this point over here across this yellow line, this is on the right side. Where should my new point be? On the left side. It should go from the right to the left side. Now, how far away is point A from that yellow line? 1, 2, 3. It's 3 to the right, so I should go 3 to the left. 1, 2, 3. And I'm going to label it A prime. Okay, what's the coordinates of that point? -3, +2. Do the same thing with the B. My B is on the left side, so if I flip it, which side should it go to? To the right side. It's 1 away on the left, so I should go 1 away on the right. What's the coordinates of my new B? 1, 3. Okay, last one. Point C is on the right, so my point C should be on the left. How many should I go over? 1. I'll label this C prime. And then I can connect my points. What's the coordinates of C prime? -1, 0. Okay, again, This is now called my image. So I went from my pre-image to my image. Let's describe the rule. What seems to be happening from the left to the right here? From my pre-image, from the blue one to the pink one. The X's this time changed their sign. What happened to the Y's? They stayed the same. So my X's changed sign and my Y stayed the same. My X's changed sign and my Y's stayed the same. So look at that. When you flip over the X-axis, your Y's change. When you flip over the Y-axis, your X changes. It's just the opposite. How do I write that as a rule? So I go from X, Y to what? If my X, negative X, comma Y. Good. Good job. Not too bad, right? Again, just making sure the important part is looking at where you're flipping it. And so if you highlight where you're flipping it, your life's easy. If you forget to highlight it, then it could be hard. Okay. Can I move on to the next one? We good? All right. Reflection 3. We're going to reflect the points across a line y equals x this time. Okay, first thing. A, B, and C. Mark them down, plot the points. So you should notice is these are the same points every single time. Start with the same triangle. Okay, now we're going to reflect across the line y equals x. Y equals x. Do you have any idea what that line looks like? Or where that line is located? That means whatever number you want to plug in for x, you should get the exact same answer for number y. So that means if you plug in a 1 for your x value, you should get 1 for your y value. If you plug in a 2 for your x value, you should get a 2 for your y value. So when we do that, right, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, it ends up making a straight diagonal line. Ooh, that's not straight. So this time we're going to reflect across this diagonal line. Ooh. Okay, so essentially here's how you can think about it. If Miss Tomasa was taking her paper and I decided to fold it right on this line here that I just created. Okay. Essentially, I'm just going to flip everything over that line, right? So my B was on the left side of this line. It should now flip and go to the right side. My A was on the right side, so it should flip and go to the left side. Does that make sense? So essentially it just flips across this line here. You might want to turn your paper so that this line is like straight up and down or straight side to side, because when it's diagonal, I think it's a little hard to figure out. All right, so if I look at point A, notice that point A is about halfway, right? It's about half a box away from this yellow line to the right side. So I'm going to go half a box away to the left side. So your points should be, they should match up and make a straight line. There's my first one, A prime. What's the coordinates of A prime? 2, 3. Good. Oh, it's backwards. Okay, if I take a look at point B is about 1, 2 boxes away from this yellow line, so I'm going to go 2 boxes away. 1, 2. Here's my B prime. What's the coordinates of my B prime? Good, 3, -1. What do you notice is happening here? They're just trading places. So what should be the answer for my last one? If it was 1, 0, what should it be? 0, 1. And that does make sense, right? It's about halfway away from this yellow line. I'm going to go halfway the other way. That's 0, 1. Good job. And I'm going to connect. So it will overlap, and that's fine. But it should look like the same thing, right? A reflection over each other. Okay, so what seems to be the rule for this problem? You just told me. What seems to happen from here to here? What flips? Good. My X and my Y's essentially just trade places. So if I were to write it as a rule, instead of writing it as X, Y, how should I rewrite my coordinates? Y, X. They just trade places. Good. All right, that one's probably, these two are probably the hardest too, because it's like a weird looking line. But again, if you can think about it, it's essentially being folded over to the other side. Maybe that'll help you. All right, last reflection. Do I have any questions on that one? All right, last reflection is reflecting the points across the line y equals -x. Okay, first thing we're going to do, we're going to label our points A, B, and C. Take a moment, graph them. All right, in the last one, we reflected across the line y equals x. It was a positive slope. Now we're going to reflect across the line y equals -x. So it's going to be the same thing except a negative slope. So instead of having a positive diagonal that goes from the bottom up to the top, we're going to have a negative one that goes from the top to the bottom. So you're going to start by drawing that as a straight line. Should go through 0, 0. And it's just a straight diagonal line. Okay, now for this one, you're thinking about if you have your picture right up here on the upper side to the right, I should be able to flip it over, and so it should go to the bottom on the left side, right? So it's up over here on the right. If I flip it, it should be somewhere over here, right next to it. Do you think you can try that one on your own? I think you can. Give it a try. It's okay if you don't get it right. Try it out. See if you can flip that yourself, if you can reflect that on your own. Try to mark the points. And if you need to fold your paper, fold your paper. If you need to turn your paper, turn your paper. He's sleeping. You do?
It looks familiar.
Well, you should. There's a whole freaking project on it.
That the one that was the project?
We like actually flipped it. You can do a picture of it.
Like we made a plan, right?
Mm-hmm. Ugh.
I should have.
So you should draw your line that you want to flip it over. It should kind of make like a straight line across the other side. Give it a try. Don't just sit there looking at it. That's great. Should be some kind of pattern. You should see a pattern with the numbers. Ooh, that does not work. Try again. Yeah.
When you go up,
Can I go up? You want to see the top? Yeah. It should look like a mirror. It should look like the same picture the other way. Okay, try it again. Your B should be right up next to it. Your B looks, or B and your C look better. Right. Your A should go a little further away.
Remember the negatives. I know, because you're saying it's 5, 2.
All right, so take a sec, look at Miss Tommaso, see which one yours looks close to. I think a lot of us look like our C's were good, right? So they should be really close together. You're essentially just flipping it right over, right onto itself. So if your shape suddenly looks like a different type of triangle, you're not doing something right. So your C should be about halfway. So this C is about halfway. My A value is 1, 2, 3 away. So I go 1, 2, 3 away. Right, so essentially it should make, your points should make straight lines. Right, they should make like 90-degree angles essentially. That's how you know if you did it right. So they should match up and make straight lines. If they don't match up and make straight lines, that's how you know you're not doing something right. So I'll give you a sec to fix yours. I'll give you a second to label your points A, B, C, and A prime, B prime, C prime. I don't see everybody's done that. I'll give you a sec to do that. And you should notice some kind of pattern. Some kind of pattern. So when we did the last reflection, reflection 3, right, which was over that same kind of crazy looking line, we said the x's and the y's traded places. What are you noticing is happening here with this line? Do my x's and my y's trade places again? So I went from 3, 2 to -2, -3. Did they trade places?
Yeah.
Yes. And what else happened? They positive to negative. And what about the one that was a negative? What did that change to? Positive. So you've got, not only are they trading places, they're also changing signs. So my rule is that my x and y trade places, and my x and my y change signs. Okay, so if I'm going to write that as a rule, how would I rewrite the x, y? What does it become? What do you think? I go from x, y to what? Negative y, negative x. Good. Okay, so let's summarize our results. These are our final bits here, all of our rules right here. It's the most important part, right? Because if you know these rules, you don't have to graph every time. You should just be able to look at the coordinates and do it on your own without having to actually graph anything. So when you reflect across the x-axis, what changed? Judge, put your mask on, please. X, negative y. Good, so the x stayed the same. The y changed signs. What happened when you reflected across the y-axis? Negative x, y. So the x changed when you reflected across the y-axis. What happens when you reflected across the line y equals x? They switched places, so it becomes yx. And then my last one, negative y, negative x, they switched places and they changed signs. Good, fantastic. All right, questions there? So if you know the rule, you don't have to graph everything. Okay, so now flip it to the back side. So some examples. It says, give the coordinates of the points after a reflection. So I've got my pre-image points right here. I want to know what are the image points after they've been reflected. So the first one asks you for reflection across the y-axis. What do you have to do if you reflect across the y-axis? For which one? And keep the y the same. So it goes from xy to negative x, positive y. So if I've got my first point is 4, 6, if I change my x, what would it become? -4. And then what do I do with the y value? Do I keep it the same or change it? Keep it the same. So it becomes -4, 6. Good. What about letter B? Change your x, keep your y. +5, +2. Last one. Change your x, keep your y. Well, can you change a 0?
No.
No. So I would just leave this as 0, -12. And there are my new coordinates. I didn't have to graph a single thing. I could figure out all of them just from the rules that I had written. Okay, next one is asking for the coordinates of the points after a reflection across the line y equals x. So do you guys actually think you can do number 2, 3, and 4 right now? Can you do these 3? All right, so I'm going to give you a minute or two. I'll give you a couple minutes, actually. I want you to just get to number 4, okay? Just get to number 4. So I'll give you a few minutes to do those few. So it just changes the sign. Okay, once you get up to number 4 and you complete, you can take your notes and you can put them away. We will go over those first thing tomorrow. And then as you're finishing up and cleaning up, a couple quick housekeeping items, a reminder. If you are retaking your Chapter 1 or Chapter 2 test, they close tonight at midnight. That means if you want to do them, you better do them. Number 2, if you are choosing to do an extra credit, they close tomorrow. You better get yourselves done if you want to do any of those grades, because if you don't do those, that's going to be tough on you. Last thing. If you are choosing to do any of the extra credits, or if you are choosing to do the chapter test, you must submit work for all of them. Yes?
What if you did it already?
If you already did it, you still need to take a picture of your work and submit it in.
What if you don't have our work?
Where would it be?
In the back?
Why would you ever throw away anything for this class? Terrible choice. Yes.
So,
Bye, dear. Have a great day.
you remember the major grade?
Mm-hmm.